I am Krishna Rao Patro, Associate Professor in the Department of CSE. So today we will discuss about one important problem, that is stack implementation using linked list. How we can implement the stack using linked list. So in the previous session you have seen how to implement the stack using array or using list also. So today we will see how you can implement using linked list. Generally when I say stack is a linear data structure which follows the last in first out order. This stack data structure which implements the two important functions, one is push, second is pop. Now these two operations you have to implement using linked list. So when I say stack, a stack is a collection of elements in which only at one end, that means at the top of the stack, you can either insert or you can delete. The insertion is nothing but push and the deletion is nothing but pop. So these two operations are allowed on the stack. Now your goal is implement these two operations using one of the programming languages. So today we will be implementing this particular concept using Python. Okay. So the elements in the reverse order in which they are inserted into the stack are excluded from the stack. The stack is often referred as a last in first out, LIFO. So the element which is inserted last, that will be pop out first. So when I say stack, always you have to represent using in a vertical list. That means in a vertical tabular form. So in stack you have to use one indicator called top. Initially the top is -1. So when the top is -1, it indicates the stack is empty. That means nothing is there. So now you are representing a top variable. This will be telling about where exactly you are, means the status of the stack, where exactly the top is available. So at that place you can insert or you can delete, or at that place you can push or pop. Assume I have inserted now 25, 33 and 21. Now currently the top is at the 21st place. So it says that top is available in second place. So whenever the next element comes, you have to insert here. So that time the top is going ahead. So the top is my main indicator. And the standard operations are push. The standard operation on stacker, one is first is push. Push is nothing but inserting an element. And remember, inserting always you have to do at the top of the stack. Next one is pop operation. Pop means what? To remove from the stack. Next is pick. Returns the element the top of the stack. That means whatever the element available at the top of the stack, that you can return. But the top element will not remove. So it will be telling about what element exists at the top of the stack. Next is full, whether stack is full or not. Is empty, whether stack is empty or not. Of course, here instead of full, whether it is overflow or not. Empty, you can say whether it is underflow or not. That way also you can display. So initially the stack will be looking like this. But this is a normal way of representing the stack. Remember, this is a normal array type. Initially the stack is empty. So here we will say top is -1. But when you are implementing using linked list, then you can make one pointer called top pointer, and the top is initially none. So whenever you want to implement using linked list, so how will you represent? Initially top is top is none. So top is none means it indicates nothing is there. Whenever one element comes, assume the data is 10 and it is none. So my top will be pointing here. Now the top of the stack is 10. And when the second element comes, one more element you have to bring here. Assume the value is 20. And this 20 will be pointed by this. So that means this is pointing here. So my top is here now. Top is pointing to 20. So that means always the top is updating. So the top is pointing to the topmost node. Again when the 30 comes, you have to insert the 30 at the top. It is none. And this will be pointing to here. So the top is again updated to here. So that means every time top is going ahead. So when I'm deleting, that means popping, That time, wherever top is pointing, that element I have to pop out. That element you have to pop out. And then the top will come down and it will be pointing to this place. So after popping, this will be removed and the top is pointing there. So this way you have to implement using linked list. So that means pushing is what? Inserting the element or inserting the node at the end of the list. Similarly, deleting at the end of the stack means end of the list is called popping. So these two operations you have to implement. Now here 21 is implemented. Now 15 is again inserted. Top is going up. After pushing 13, 24 and 11 and 35, the stack will look like this. Earlier 21 and 15 were there and now you have inserted these 4. So the top is going to topmost of the stack. Similarly, after pushing 51, of course for stack there is a limit. When it goes out of the boundary, then there is something called overflow condition. That is possible in the case of limited stack size or array size. Whereas in the case of linked list, you can put the count also. But here the array size, when it goes out, that time you have to check because it is a static memory allocation. Whereas your linked list comes under dynamic memory allocation. So there overflow situation may or may not come. Whereas here, when it reaches the boundary, automatically you will get the overflow situation. Similarly, when I say pop, so which element will pop here? Because there are many elements are there, but which will be pop out? So when you say pop, always the topmost element will pop out. That means whichever at the top. So this element 35 is popped out. 35 is popped out. Now the topmost element is now 11. So that means the top has come down. So this way it's popped. Similarly now, please remember now how many elements are there? 1, 2, 3, 4, 5. 5 elements are there. Now assume I will do multiple pop operation. Multiple pop operation. So when I say pop 4 times, what will happen? That means 4 elements will be popped out from the stack. So after removing this 4, because out of 5, 4 popped out. Only the last element 21 is available in the stack. So top is now pointing to the last but bottommost element. Again when you say pop, this element is popped out. The top has come to -1. So whenever -1 comes, now if you pop out, there is a underflow condition. So overflow and underflow are the two situations in the stack. Overflow comes whenever the stack is full, still you want to push. That time overflow comes. And underflow comes when the stack is empty, still you are removing. That time underflow comes. Okay. Now we'll write a program using Python. Using Python, how you can implement the stack using Python. So whenever you want to implement using linked list concept, the linked list is managing all the elements in terms of the node. In terms of node. So linked list is nothing but collection of nodes. Collection of nodes. This node you have to represent. In every node, you should have the data part as well as you have the link part. The data part will be really holding the real data and the link part which is pointing to the next node. So the linked list you have to maintain this way. So when I say node, the nodes having data part as well as you are having next part because next is pointing to the next node. So this node I am representing in this way because I am using my object-oriented concept. So write a class called node and whenever node is created, I am calling my constructor. Automatically constructor will be called and in the constructor I am passing my data. This data is stored here and this way the node is created. So this is the node representation. Similarly stack. Now you are implementing stack using linked list. So there I am maintaining one special pointer called top pointer. What is the top? Top is the pointer which is pointing to topmost node. But initially there is no node at all. There is no element at all. So that's why top is none. So there Where you have to initialize? You have to initialize in the constructor, because whenever the stack object is created in the constructor, you have to initialize this way. Okay. Next, the special methods you have to write whether stack is empty or not. This empty method will be useful whenever you are popping out. Whenever you are popping out, always you have to check whether the stack is empty or not. If the stack is empty, you cannot pop out. If the stack is having some elements, if it is not empty, then you can write this method. So there you can put a condition. Top is none or not. If it is none, it is empty. That is return true. If it is not none, then come to else part. So return false. So that's why I am writing this simple method. So this is a simple method to check whether stack is empty or not. If stack is empty, return true. If stack is not empty, return false. Now, two more important methods, that is push and pop. These are the two standard methods for stack. Remember, push is one of the important method in the stack. Similarly, there is another method called pop. Push and pop. New node equal to node of data. That means I have created the node. This node class is called now, means the constructor is called. Automatically one object is created. So new node. Next, self dot. Here I am checking whether you are coming first time or not. If it is first time, self dot top is none. Then assign the new node to the self dot top. If it is not none, that means some elements are still exist. Then new node dot next is equal to self dot top, and self dot top is equal to new node. So that means the top is always going to topmost place of the stack. So this element you can imagine in this way, because when I say stack, always you have to imagine in a vertical manner. So this node, now it is pointing to, for example, this is 100, this is 200. So now this 200 will be available here. That means this node's next is now pointing here. And currently this node is pointing to nowhere. Assume my data is 5, this is 6. So this way you are able to insert. Again, if you assume you want to insert 7. So now my top is always moving. Now top is here. Earlier top was here. Now top is here. Assume its address is 300. Now this 300 you have to update in this place. So here you should update 300. So that means pointing here. It is pointing to nowhere. So every time the topmost element will be at the top of the stack. So this way you are doing the stack operation using linked list. So here in the push method, every time I am updating my top. So when I say pop, pop means what? You have to remove. So while removing, you have to check whether it is empty or not. Already you have written a method called is empty. Now I am calling this method. It will check whether top is none or not. If it top is none, it will say underflow. There is nothing is there. You cannot remove. Otherwise, if it is not empty, it comes to else part. There, I have taken the popped element. So popped node equal to self dot top. Then pop node data. I have simply displayed the what element you have removed. And then pop node equal to none. So that means whatever the node you have deleted, that next part I made it to none. Otherwise, that will be a dangling reference. So that's why I made it none. And that node can be dereference. Similarly, you can write another method called show. So when I say show, it has to display the element of the stack. So I made one top. Already top is there. Top is the top of the element. Initially I stored in the temporary variable t. So t equal to self dot top. And those data of the stack you have to display in the top to bottom order. So put a loop because multiple elements are there. So repeat a loop. So while t and print the data part. T dot data. After printing the data, the top should come down. So t equal to t dot next. But here I am not updating my t, means your top. That's why I am making one temporary variable. The temporary variable is updating. So it is keep on going. Whenever t is none, it will stop. If t is not none, every time it will print the data and t will come down. Because I am coming from top to bottom. So whenever you are coming to bottommost node, that time t dot next is none. So whenever t is none, the loop will terminate. So this way this program is, and then finally you can create one stack object is created, then stack dot push. So automatically what happened, 10 is push, 20 is push, 30 is push, 40 is push. So now currently my top pointer is pointing to this node. Now when I say stack dot show, what will display? It will display 40, 30, 20, 10, because I am going from top to bottom. Now when I say pop means the topmost element will be popped out. So 40 will be popped out. Now the top will come down. So always the top will be coming down after popping. Again when I say pop, then 30 will be popped out. So here 40 popped out, here 30 popped out. So after popping out, the top is again coming down. So that means the top pointer is pointing to the second node. So when I say show, it will display 20 and 10. So 20 and 10 will be displayed. So show method is displaying the elements of the stack from top to bottom. Again when I say pop. So first time when I say pop, 20 will be removed and the top is coming down. Again when I say second time pop, the 10 will be removed. So now currently the stack is nothing. That means stack is empty. Now when I say show, it will say nothing found. Simply empty. Now when I say again pop. So when you say pop, now nothing is there. So what will pop? So it will say underflow. It is underflow. So here underflow. And here also underflow. So when I say show, nothing will display. Now no elements are available. So this way it works. Now let us write the program for this. Now I have opened my idle environment. There we'll type the program. So our goal is what? Stack implementation using linked list. Stack implementation using linked list. Okay. So let me still enhance the size. Input idle 29 is enough. Okay, fine. Now I told you first of all you have to define a class node colon, because every time the class must be entered with a colon symbol, class name, and you should write the constructor underscore init underscore, and this is your constructor. So write the first keyword self as well as the data, whatever the data you want to pass, you pass the data. And here you have to initialize, means whatever data you are passing, you have to initialize with your member variable self dot data equal to data. So data is assigned to the node. After assigning this data, and whatever the next, because in every node there will be two parts, data part as well as then next part. So I will write here self dot next equal to, initially you do not know what data is there, that's why none. So self dot next is none. So my class is ready. Which class? Node class. Now this node I have to use in my stack. So I have to write one second class called stack. So here I will write class stack, and the stack is not built in. This is user defined. You would write. So class stack. Here I will have to write my constructor for the stack. So how to write constructor? Def underscore init underscore self comma data colon. Here I have to maintain one special pointer called top pointer, because in the stack the top pointer is always pointing top of the stack. So initially nothing is there, so you have to initialize the top pointer self dot top equal to none. So it indicates that this list is empty. So my top is ready. Then you have to write the important methods for stack. First of all, I have to write push method. Then I should write pop method. Then I'll write my show method. Then I'll write my special methods. So let me write my push def underscore underscore. Of course, this is not a built-in one. This is my user defined. So push is my own method, and I want to make this method is a member of the class. So whenever you want to make member of the class in Python, then you would write a keyword called self. So self, comma, self dot what you want to push the data. So you are passing the parameter data. After passing the data you have to insert as a node. So you have to create a node first. So I will create the new node equal to node, because node is my built-in, not sorry, user defined class. So here I am passing my data, whatever data I am passing here. So new node object is ready. Now this new node you have to insert into the stack, push into the stack. So before pushing, you have to check whether it is first time, whether stack is empty or not. If it is empty, directly we will assign the top to the new node. If it is not empty, then I will update, either assign or update. So I'll put a condition whether it is first time or not. If self dot top, that means I'm checking whether it is first time or not. If self dot top is none, it indicates what? Top is none. It indicates stack is empty. So here I'll write here self dot top equal to the new node. So my new node is ready and assigned to top. Otherwise, else, if it is not none, then else part. So if it is not none, my new node is available. It should be available at top of the stack. So I should write here new node dot next, because when the node is created initially, the next is none. But here I will not assign none. Here I will assign with the current top of the stack. So here self new node dot next equal to self dot top. So my top is here. And the top should go to new node now. So self dot top equal to the new node. So now my top pointer is pointing to the new node. Whatever the node you have inserted or push, that is the top. So after pushing, I will print a message. Print here, print data inserted or data push. Data push. PUSHCD push, comma, the data. Whatever the data you are pushing, you are writing. Okay. So my push method is. Then I will write another method called pop. But before writing pop, I will write a method called whether the stack is empty or not. So I will write a method called is empty. Is empty. This is not built-in method. This is user defined. So this method also my member of the class. So I will write here self. Here what I will do, whether stack is empty or not. How will you check stack is empty or not? For that, there is a indicator called top. So the top, whether it is none or not. So I will put a condition if self dot top equal to none. If this condition is true, if self dot top is none, it says nothing is there. So I will return true. So return true. Otherwise, else return false. So either true or false will be returned from this method. Def pop. Now I'll write my pop method. This method will be using this isEmpty method. So here I want to make the pop as my member method of the class. So I'll write here self. So here what I'll do, I'll write my own method. Now before that, before writing, let me check my driver method. My class is over. So here stack is my class. STK is my object. My stack is ready. Now here I'll write STK dot push 10. STK dot push 20. Now 10 and 20 I want to push. Let me first show whether it is working or not. Control S7 STK F5. Press F5. Now it says invalid syntax because here double you are comparing. Comparing means you should write here, write double equal to, because you are comparing. Whenever you are comparing, you have to write the relational operator. Control S F5. Yeah. Missing one parameter. When I say init, it must have the self method, means self variable. Init self data, and in the stack you are not going to pass anything because nothing you are passing in the stack. So don't write the data. Simply say self dot top is none. Control S self. Yeah. So now 10 is push as well as 20 is push. That means pushing method is running perfectly. Now pop method. So when I say pop, so here what I'll do, I'll write a pop method def pop, and I want to make this as a my member method. Self so here I'll check whether it is empty or not. If self dot is empty, that means this method will return either true or false. If it is true, that means some elements are necessary. There is no element. So here I'll simply display message, because for stack, if nothing is there, still you want to pop. So you have to display message. So what should the message? The message is print underflow message. Underflow. Remember, underflow is a special message for stack, because you are trying to pop out the element from the empty stack. That is underflow. Else, if some elements exist, else, here what I have to do, the pop data, the popped node, nothing but wherever the top is pointing. So self dot top. So my top pointer will give the pop data, and the top should come down. So here I'll write self dot top equal to self dot top dot next. So when I write this statement, automatically the top will come down. So now top is pointing to next element. After that, I'll print a message. What are the data you have popped out? The popped data. Popped node is nothing but my popped node dot data. So automatically my popped element means popped node data displaying there. So after popping out, the node has to be detached. So that means the pop node's next part must be pointing to none. So I have to make it none. Pop node dot next, because it has to be detached from the original list. So I should make it to none. If you are not writing none, what will happen? Still that will be there. Will be still pointing there. So that's why you have to detach it. You have to completely remove from the list, because you are popping out. That means you are removing. It should not be attached. Okay. So this is your pop data. Now let me show whether it is popping or not. Now here I'll call pop. STK dot pop. So because here I am calling this method. So I have created already the object called stack. STK dot pop will be calling that method. Yeah, the pop node is 20. Because now initially 10 was there, then 20. Now from the top of the stack, it has removed. Now if I write second time, one more pop. stk dot pop. What will happen? Control S F1. Yeah. Now first 20 popped out, then 10 popped out. Because it is following last in, first out order, LIFO. Again, if I say stack dot pop, now it has to say underflow. Yeah. Now at the bottom you see there is a underflow message. Underflow message. So it says that nothing is there. Now stack is empty. Now if you want to display what element exists in the stack, let me write def show method. I want to make my own show method which will display the data from top to bottom. So, but you want to make this as a member method. So if you want to make this as a member method, then you should write the keyword called self. So self is a keyword which makes the method to method of the class. So write always self in Python. Now you have to display all the data from top to bottom. So, but top pointer I should not disturb. That's why I'll take one temporary pointer t. So t equal to self dot top. So that means what? I got the topmost address. From that node, I should come down because in every node there is a next pointer. The next pointer will be coming down. Keep on going down. Whenever you reach none, then stop. Last nodes, the next part will be none. So whenever you reach none, then stop the loop. So I'll put a loop while t. If t is true, then it has to come down. So I will print a message, print t dot data. So after printing this data, then I have to come down. So every time I should give a space, end equal to space, and the t should come to next. T equal to t dot next, because next pointer always holds the address of the next node. So it is keep on coming down. So before the loop, I will print a message, print the elements of the stack. Elements in stack from top to bottom. So from top to bottom I am showing. Fine. Now let me call this show method so that it will display. I will, because here already stack created and two elements are push and pop and they popped out. After pushing, I will call stk dot show. So when I call show, it will display the elements available in the stack. So already you have pushed what? Now in my stack, initially 10 is push, then 20 is push. So when I say show, it will display from top to bottom. So that means first it will display 20, then it will display 10. So let us show now. Control S F. Yeah. Now the elements in the stack, it is showing 20 and 10. But it has to come to next line. That's why in the pop node I will put new line. I will put pop node. Here I will put a base class n, so that next time when it's printing, it will display the next line. As well as here also I will put a base class new line. When I write base class n, it will come to next line. F5. Yeah, it has come to the next line. So the elements in the stack from top to bottom 20 and 10, and popping node 10, pop node 10. So this way you are able to show. So that means you have implemented push method, pop method, and show method is empty. So all this method you have. Of course, if you want to show which element available at top of the stack, which element available without popping, I want to show. So in that case, you can write a method called peek. So the peek method you can implement now. So let us write peek method. Def peek method. Peek is my special method which will display which is means what element available at the top of the stack, and you want to make this as a member method. So you should write a self keyword, self. Now what you have to do? Whatever the element available at the top, that you have to show. So now you can check if self dot top, if it is equal to none, if it is none, it says what? Nothing is there. So here I'll say no element found or stack is empty. You can say print stack is empty. So you can display a simple message whether stack is having some data or not. If this is not empty, that means some elements are there. Then you can display print. So how will you display the topmost element? That is nothing but wherever top is pointing, the top's data you have to show. So that means you can write here the topmost data or top element, the top element of the stack, element of stack. How much? That you have to say now top dot, because now top is my member, so I should call self dot top dot data. And remember, in object and programming, whenever you want to access any member of an object, you have to use the dot operator. Dot is called accessing operator. So take the accessing operator, try to access it. Now this peek method I should call now through object. So how to call? So here let me remove these two. Already you have seen now. Now I'll write stk dot peek. That means what? I'm calling the peek method of the stack object. So after popping, let me push 3 or 4, 20. Here I'll write 30 and here I'll write 40. That means I'm inserting 10, 20, 30, 40. So at the top of the stack, 40 is there. But when I say pop, the 40 will be popped out. And now after popping out, now when I say peek, okay. Before popping, I'll say peek. Here, I'll display first peek, then pop. Control S, F5. Yeah. The element in the, now here I wrote the topmost element of the stack is 40. Okay. But you want to print this also in the next line. So if you want to print in the next line, what you have to do? Always put a \n at the beginning so that it will come to next line always. It will not mix with the previous line. So \n is a new line character so that you can insert in the beginning of the string. So remember, in Python, in C, in C++, in Java, you can write this new line character. So to print the line in the next line, Control S. Yeah. Now it has come here. The top element of the stack is 40. So top, this is your peek method. After that, I call pop node. So 40 is popped out. After popping, what elements are available? Remaining elements. Now you want to show. So how will you show? Now after that, I'll show. stk dot show. stk dot show. Now when I'm calling F5, yeah. Now the elements in the stack from top to bottom is 30, 20 and 10. So this way it is showing. I hope it is clear now. And they may ask a simple question even in the exam. What is the time complexity of the push operation, as well as what is the time complexity of pop operation? Remember, the time complexity of push as well as pop is order of 1, because whenever the element is pushed, always it will push at the top of the stack. So it takes constant amount of time. So whenever it takes constant amount of time, that is order of 1. So the time complexity for push operation is order of 1. Here let me write here through comment. Time complexity. Time complexity is order of 1. Whereas for pop, the time complexity also order of 1. Why order of 1? because pop also wherever top is there you're doing. So it takes constant time. So whenever it takes constant time, you can write order of 1. So this way you can. So pushing and popping always one important method for the stack. So try to implement in this way and you can solve any kind of problem. So one of the very, very important question for your laboratory exams, even in the interviews also. Prepare well. All the best. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.